going to explore the geology of Red Dead Redemption 2 and how the landscapes might have been formed if they actually existed. What's cool about the game is that there are many connections to geology, and it even has a mission called Geology for Beginners. The game shows a lot about mining, so we see many abandoned mines, excavated tunnels, and this search for gold. This makes sense within the geological context of a mountainous region with intrusions, veins, and hydrothermal systems, and gold-bearing veins associated with fractures. Starting from there, and of course I'm trying to connect something fictional to real events, the presence of gold suggests the circulation of hydrothermal fluids linked to tectonic events, such as the opening and closing of a basin, for example. It's interesting to note that the map follows a certain logic here. So we have the mountains, which are the sources of sediment, the rivers for transportation, the plains for deposition, and deltas and swamps for fine accumulation. So there is a sedimentary cycle that is visually coherent and not random. We're talking about a game, so not everything is real. The scale, for example, is very compressed. Processes that in real life would be many kilometers apart are just a few minutes away on horseback. So of course, this aspect of the map isn't realistic. We're going to explore 4 main regions: the Heartlands, which are the sedimentary plains, the Grizzlies, which is that mountainous area, New Austin, which is an arid environment, and this tricky name here, Bayou Noir, which is a swamp system. Let's start here by exploring the Grizzlies. We see imposing mountains and snow-capped peaks. Geologically, they represent the core of an ancient mountain range. But how do these mountains form? We can compare them to the highest mountain in the world, the Himalayas, where Mount Everest is, or even to the Andes. All of these are places where we find such mountain ranges. And they were formed by the interaction of 2 tectonic plates that converge. In other words, they move closer together and collide, lifting this massive land that will then form our mountains. And why does this happen? Well, we have convection currents in the mantle, which are basically rocks with a liquid part that move slowly beneath our lithosphere, which are the plates. So if these plates are floating, so to speak, on this sea of magma, they are also moved by it. So, many millions of years ago, we had a different arrangement of the continents, as we've already mentioned. Pangaea, Rodinia, and the Himalayas, for example, were formed when the tectonic collision between the Indian plate and the Eurasian plate occurred, which closed the ancient Tethys Sea. And this collision pushed the crust upward, since it was the collision of 2 continental plates. And there we can clearly see the shape of the Indian plate colliding with the Eurasian plate and forming our mountains. Mountain ranges are formed by rocks like granite, the same kind we have on our tables at home, and through metamorphism, that is, during this collision, they may have transformed into gneisses, which are these rocks that look like this. They have a very characteristic banding, which are these black and white lines representing mineral segregation. So, under high pressure, the different minerals that make up the rock, such as granite or sedimentary rocks, begin to separate into distinct rocks. The light layers are formed by minerals such as quartz and feldspar, while the dark layers contain mafic and platy minerals, like biotite and amphiboly. These rocks resist erosion, and so they create those sharp peaks and deep valleys just like we see in the game. And the landscape we see is the result then of this tectonic uplift, these ancient folds and faults. All of this combined with glacial erosion, so we can see that we're in an environment with a lot of ice. This ice carves out the famous U-shaped valleys and steep slopes. So sometimes the glacier carries rocks and sediments at its base, which act like sandpaper as it slides over another rock, so it wears down the rock underneath. Another way ice acts is that water from the ice seeps into cracks in the rocks, freezes, and then expands. We've seen this before, for example, when we can't leave a closed water bottle in the freezer because it will break. The same thing happens with rocks. The ice expands, breaking off pieces that are then plucked away and incorporated into the moving glacier. And these U-shaped valleys are formed because glaciers widen and deepen the valley floors, creating those steep slopes and flat bases. But if we go down to the Heartlands, the scenery changes completely. And then we start to see these gentle plains, those isolated little hills, and the rivers that lazily wind through this landscape. And here, the geological base is made up of fluvial and lacustrine sediments, so they come from rivers and lakes. And we'll have sandstones then, which are rocks basically formed from sand, and siltstones and mudstones, which are rocks formed from clays. These layers are deposited, forming these very clear transitions between layers, and over millions of years, they end up solidifying into rocks, either due to the pressure from adjacent rocks or for other reasons. So our layers will be quite horizontal with little deformation, because to deform a layer, we would need to have some metamorphism. Movements of tectonic plates. But we are there on a plane that is already defined, showing how sediments accumulated over time in stable basins. So the erosion that happens there will create hills, remnants, which are those little hills we see, and each bend of the river will tell a story of sediment transport and deposition. It's the opposite of the mountains, so there we have calm and linearity. But if we go further south to New Austin, we enter the desert. And in the desert, there's a lot of action from the wind and weathering. So the soil is very dry, and the wind and water will shape mesas, exposing layers of colorful bands, conglomerates, and limestones. What happens there? When we see these formations like a mesa, it's because the top of these formations is made up of a much harder and more resistant layer of rock. And beneath this cap, there are softer rocks like shale or schist, which erode much more quickly due to water and wind. In other words, rainwater and wind will wear away the sides, but since the top is hard, it will protect the rock. And this creates vertical walls while the surrounding terrain lowers. Similar to what we have here in Brazil in the Chapada Diamantina, this region will then simulate intense erosion, where intermittent rivers and mechanical weathering will carve out canyons and valleys, leaving several visible layers. And finally, we arrive at Bayou Noa, where water dominates. So we have a swamp environment, in other words, very humid. And here, the sediments are fine, so we have clay, silt, peat, deposited slowly in a low-energy environment. So think about it, if we don't have a river flowing, if we don't have a sea, if we don't have any force there, these swamps and deltas will be calm. And this sediment gradually settles, falling into the lake, and along with it, we have organic material. That is, the little animals that die, the leaves that fall, and all of this accumulates because there isn't a force to carry it somewhere else. A few years from now, they could, for example, form layers of coal. It's a landscape that seems more alive, right? Well, that was a quick analysis of the landscapes in the game. If you enjoyed it, give it a like and subscribe to the channel. Bye-bye!